Oscillations Part-2. In this video, we'll be discussing about the solutions of simple harmonic motion. Also, we'll be discussing about the displacement, velocity, and acceleration of the simple harmonic motion at different times. So, let's get back to the classes. Stay tuned and enjoy. A warm good morning to all of you. Today, we'll be speaking about the differential equation of a simple harmonic motion and to find its solution. In my earlier video class, I did talk about how to find or how we got the differential equation of a simple harmonic motion. Just a recap of what I had told you earlier. As we had seen that with the example of a block of wood attached to a spring, you could see that when it is pulled to a distance x, it retraces back to another extremum position, that is a minimum position, apart from the equilibrium position. So we can say that once you pull the block, there's a restoring force happening to it. So force is always, we link it to the Newton's second law of motion. That is, in terms of x, we can write acceleration as d square x by dt square. A minute, just change the color. It's d square x by dt square. So force means m mass into d square x by dt square. This is proportional to the displacement, okay, x, that is in the opposite direction. See, it is going back to the equilibrium position, so it's a minus x. So we just, how did we get the equation? M into d square x by dt square is equal to minus kx. So dividing throughout by m and taking everything to one side, you have d square x by dt square plus k by m x is equal to 0. And this k by m, we have put it as equal to the angular frequency omega square. And thus we have got the equation, the differential equation for the simple harmonic motion as d square x by dt square plus omega square x is equal to 0. So these are differential equation for simple harmonic motion or simple harmonic oscillator. So let's put this as equation number 1. Okay. Now we want to find the solution to this. This is an equation, so there should be a solution to it. So to arrive at the solution, what we do, we pick this d square x by dt square, the acceleration d square x by dt square. So just look what I have done. So d square x by dt square is also written as is a differential of dx by dt, right? Now what is your dx by dt? It is nothing but your velocity. So this equation can be rewritten as d by dt of v. So now you have dv by dt, and that you know very well, it is an acceleration. Now this we can write it in a different fashion, that is this equal to, okay, dv by dx into dx by dt. It's the same thing, only thing that you have multiplied and divided by dx. So again we have dx by dt is nothing but v, so we can write this as v into dv by dx into v. Okay, so now you can replace d square x by dt square in equation 1 by v into dv by dx. So this is the equation number 1. So here we can write v into dv by dx. So I am going to give this equation. I am reformulating this equation for the solution. So it's a solution to differential equation of SHM. So we have found that d square x by dt square can be written as, just tell me, it's v into dv by dx. That you can write it as equal to minus omega square x. Okay. So take everything to one side, the common things. So I'll just write this also. So this is equal to v into dv is equal to minus omega square x dx. So just integrate this equation. So just we'll put this as equation number 2. Integrating equation 2, we have integral of v is v square by 2 is equal to minus omega square. Again you have x dx. Omega square is a constant, so the integral of x dx will be x square by 2 dx. Then the constant of integration c. Now we have to find out this constant c. You cannot just claim that it is just a constant. Now we have to find the constant c. So for that, what we do is we apply the boundary conditions. That is, when x is equal to plus or minus a. Okay, when x is equal to plus or minus a, what happens? We have v is equal to 0. Why? In the extreme positions, you have the velocity as 0, and therefore the equation becomes c is equal to omega square a square by 2. Right? This will is 0, and then x will become, if it is plus a also, it is a square, minus a also, it is a square. So it is omega square a square by 2. So we'll just put this as equation number 3 and this as 4. So substituting 4 and 3, you have v square by 2 is equal to minus omega square x square by 2 plus omega square a square by 2. From this you can obtain v as equal to, so you can just cancel out the 2 all together. So we have v square is equal to, you can pick omega square outside, then you have x square minus a square minus x square, right? So therefore your velocity v is equal to omega into root of a square minus x square. That's in terms of the velocity, but you know your differential equation is in terms of x, so we have to get the displacement also, right? So now we can write v as equal to dx by dt is equal to omega root a square minus x square. So again what we do, we again bring all the x to one side. So your root of a square minus x square becomes a denominator on the left hand side, and on the right hand side you end up with omega into dt. Now again next is we have to integrate it. So when you integrate it, you know dx by root of a square minus x square is nothing but sine inverse x by a is equal to omega into dt. Integrate, when you integrate you will get it as t plus some constant, say phi. or this can be written as x by a is equal to sine omega t plus phi, or x is equal to a sine omega t plus phi. So this is our solution to the equation 1, d square x by dt square plus omega square x is equal to 0. The solution is x is equal to a sine omega t plus phi. This is my 6th equation. So you have your x in your hand, so you can doubly differentiate to get your acceleration. So we can just differentiate once. So dx by dt shall give you a omega cos omega t plus phi. Otherwise it is also known as the velocity v. And then acceleration will be d square x by dt square, that is differentiate once more. So it becomes minus a omega square sine omega t plus phi. Okay, phi here is a phase. Now the sine omega t, a sine omega t is nothing but your x. So this can also be very well written as minus a, it's minus omega square x. So this is your acceleration. So let's put this as equation number. Here we'll put this also. We require all this for a future explanation. This is 7. This one is 8. So this is my 8th equation, and this will be my 9th equation. So we have found the displacement, velocity and acceleration of the SHM, simple harmonic motion. Now how do you picture this graphically? That's really interesting. And the only thing you have to know or keep in mind is that the time period, okay, the time period t is equal to, as you all know, it is equal to 2 pi by omega, the angular frequency. So time period is equal to 2 pi by omega. So now we'll just go into the case discussion of the displacement. So we'll just take up the first one. Graphical description of displacement. So in a 2D graph, you require 2 axes. So one is displacement, the other will be your time. Sure, you want to know the displacement at different times. So that is what we require. So we'll start with our equation 6. Yes, equation 6 is nothing but x is equal to a sine omega t plus phi. This is your equation. So we'll take up that equation. X is equal to a sine omega t plus phi. Now, as I told you, the time period is t is equal to 2 pi by omega. So let's put it in terms of the time period, because we want displacement versus time graph. So this will become a sine, so omega will be 2 pi by t, 2 pi by t into t plus phi. So here we assume that phi is equal to 0. The phase is 0. So when you assume phi is equal to 0, this equation again reduces to x is equal to a sine 2 pi by t into small t. Now let's get into different possibilities, cases. So case 1, that is t is equal to 0. So what happens? Just look at the equation. When you substitute x is equal to a sine 2 pi by t into 0. So this becomes 0. X is equal to 0. Okay. You get the first position. So x is equal to 0 at t is equal to 0. That's a case 1. Okay. In next case. Case 2. T is equal to t by 4. Okay. When it reaches 1/4 of its period. Now what happens? When you substitute in equation 6, x is equal to a sine 2 pi by t into t by 4. Okay. So this becomes t and t gets cancelled. It becomes sine pi by 2. And you know sine pi by 2 is nothing but 1. A sine pi by 2. So x will be equal to a. This is the maximum amplitude. X will take the maximum amplitude for t will be equal to t by 4. Okay. So now you can just imagine. So you have this as displacement. Okay. I'll just do it in another color so that to be more relevant for you. So let's take the red itself. It's quite attractive. So this is the displacement. And this is the time. So at 0, the particles here itself. In the case of t pi by 4, so this is 0. So maximum displacement is a. So in the case of t pi by 4, t is equal to t by 4, it will be maximum. So the particle will be here. So the particle goes this way. Okay. Now let's look another point. When it is t by 2. Next possibility, t by 4 is over. So next possibility is, so now we have displacement is here. Okay. A. Now next one is we are talking about when t is equal to case 3. Okay. Case 3. T is equal to t by 2. Now it is half the period. So what happens to x? X is equal to, just put down it. So just substitute for t, a sine omega is replaced by 2 pi by omega into small t is into t by 2. So t and t gets, here it's t and t gets cancelled. So we have this is equal to a sine pi. And you know sine pi is nothing but equal to 0. So x will be equal to 0. So what happens? I can draw this. So here it is, correspondingly here it is t by 4. This time axis. Next at t half. So this portion, you can see that here it will be t half. So it will be 0. Okay, the displacement is 0. Now talking about the next case, that is t by 2 is over. So we have the fourth equation, fourth case, case 4, that is t is equal to, small t is equal to 3t by 4. Now substitute in the same equation, x is equal to a sine 2 pi by t into small t is 3t by 4. So 2 and 4 gets cancelled as 3 by 2 pi. It's done. So sine 3 by 2 pi is nothing but minus 1. Sine 3 pi by 2. And this 3 pi by 2 is equal to minus 1. So your amplitude is x is equal to minus a. So we'll just come back to the same this thing. Okay, I'll draw another one that is probably better. So I have multitude this thing also. Let's cut this off. So we have another diagram. So here I'll just draw it in a smaller way. So you have 0 here. This is t is equal to t by 4. And this is t is equal to t by 2. Now we have got it as t is equal to, what is it? 3t by 4. So you have seen that. So I have to draw the negative axis also. So we can see that it's the graph is maximum here. If it is A, this is maximum. So here it is maximum. Then here it is minimum. Then here again it is minus A. Sorry, minus A. Minus A here. Now another possibility is your fifth case, that is case 5, when t is equal to capital T itself. Then your equation becomes x is equal to a sine 2 pi by capital T into t. So it is x is equal to a sine 2 pi, and you know sine 2 pi is nothing but equal to 0. So this is equal to 0. So this equation at t is equal to t will again become 0. So you can see that it is a sine wave. So our solution agrees with the graphical representation also. So beginning from 0, you end up with at t is equal to t as 0 itself. So one full time period has been completed, and you can see that it is a sine wave. So I have an this thing. Let me see this. You can just visualize. So here you can see that at 0 the particle is at 0. Okay. Then it gets maximum when it comes to this position, and then again goes to minimum at pi, and goes to a negative minus a, amplitude at 3 pi by 2 and 0 at 2 pi. So this also, I think I have to change it so that I can just talk to you about the velocity. Okay, coming back. Now come for the case of velocity. So again, in the case of velocity versus time graph, okay. Now we can see that V is equal to, you have seen the equations, I just don't want to scroll much, forgot. So you can see that we have V is equal to omega under root of a square minus x square. Not only that, again we were taught that V is equal to dx by dt in terms of sine, cosine function, it is a omega cos omega t plus phi. So we'll take that equation for the graphical representation. So V is equal to, what we saw, is equal to a omega cos omega t. So let's substitute for omega here, only here, so that we can write the cos values. So omega, as we saw earlier, omega is equal to nothing but 2 pi by t. So what will your V be equal to? V is equal to a omega cos 2 pi by t into t. Now, as before, we can just discuss the cases. So the case 1 was at t is equal to 0. Okay. So what happens? V will be, what was this equation number? One sec. I just forgot the equation number. I should have checked it before itself. I'm really sorry for it. So it is equation number 7. Okay. So this is my equation number 7. So case 1 at t equal to 0. Now equation 1 becomes V is equal to a omega. So t is 0, that means it is cos 0. So cos 0 is nothing but 1. Okay. So it is a omega, the maximum value. Okay. We'll just do it, the graph we'll just do it afterwards. So let's put this as a. Next case, what will it be? At t is equal to t by 4, 1/4 of the time period. So it will become V is equal to, substitute in your equation number 7. So V is equal to a omega cos 2 pi by t into t by 4. So you know it is cos pi by 2, and cos pi by 2 is nothing but 0. Therefore the whole equation 7 gets to 0. So this case V is equal to 0 at t is equal to t by 4. That's my second case. As against your displacement, at t equal to 0, it is 0. Whereas at t is equal to t by 4, it is maximum amplitude A. And we did talk about the solution also in the, in in our earlier derivation where we had told that v is equal to 0 at the extreme positions. This is how it comes to, okay? At the extreme position, the velocity. Maximum position will be the where the displacement is maximum. So at that point, that is at x is equal to a, the velocity is equal to 0. Just a reminder of what I had told you earlier. Case 3. So case 3 is at t is equal to t by 2. Half the time period. V will be equal to a omega cos 2 pi by t into t by 2. So 2 and 2 gets cancelled, and then and t gets cancelled. So you end up with pi. So it is cos pi. V is equal to a omega cos pi, and cos pi is nothing but minus a. Minus 1, sorry. It is V is equal to minus a omega at t is equal to t by 2. Again, the next case, just remember what it was. It is 3/4 of it, no? So t is equal to 3t by 4. So V is equal to a omega cos 2 pi by t into 3t by 4. So you have 3 by 2. So a omega cos 3 pi by 2, and cos 3 pi by 2 is nothing but 0, and V's will be equal to 0 at 3t by 4. And next case is case 4 at t is equal to capital T itself, time period. So V is equal to a omega cos 2 pi by t into capital T. It is cos 2 pi. A omega cos 2 pi. So that is equal to a omega itself. Now let's draw the graph. This is the case 5. So let's give some marking. This is 0, t by 4, t is equal to, this is time graph, no? T equal to 4, t is equal to t by 2, t is equal to 3t by 2, and this is equal to t is equal to t. And let's put the maximum displacement will be a omega, and here it is minus a omega. So let's draw the graph. So you know, first case is at 0 it is a omega, at t by 4 it is 0. Okay, we just mark the points first. Then at t by 2 it is minus a omega. At t is equal to 3t by 2 it is 0, and again at t is equal to t it is maximum amplitude. So we'll just draw the figure. So it is this figure. Okay. So it will take, now it will again go to 0. Okay. And then it will continue as it is periodic motion. Okay. Now we have to talk about the acceleration. Okay. So I'll just add a few more pages. So about the acceleration. In the 8th equation, we have seen that acceleration A is equal to, we have, let's put it as A gets confused with our amplitude A also. So I'll just write it as acceleration itself. People give it as alpha also. Acceleration is equal to minus A omega square sine omega t plus phi. Okay. So that is how acceleration was defined in the equation number 8. So again, you can I'll go very fast. Case 1, t is equal to 0. That means we have to substitute for omega. Omega is equal to 2 pi by t. So the equation actually we have to substitute is acceleration is equal to minus a omega square sine 2 pi by t into small t. So at t is equal to 0, acceleration will be 0 because it is sign dependent. Now next condition is t is equal to 1/4 of the period. So what is it? T by 4. T by 4 means it is pi by 2. So acceleration is equal to minus a omega square. Again at t is equal to t by 2. Acceleration will be sine, it is pi, that is equal to 0. Again t is equal to 3/4 of the, so 3t by 4. Acceleration will be sine 3 pi by 2, that is minus 1. So this minus and minus gets positive, it becomes a omega square. Again at t is equal to t, the full period, acceleration will be sine 2 pi, that means it is equal to 0. And so we can have the graph as this is, we can mark it as this point as a omega square displacement. This is displacement, no? And this as minus a omega square okay. So at t, this is t by 4, t by 2, 3t by 4, and this is t. So at t is equal to 0, it is acceleration will be 0. So this point is 0. Then at t by 4 it is minus a omega square. So this is the point. Then t by 2 it is 0. 3t by 4 it is a omega square. So point it here. And again at t is it is 0. So we have, you can draw through the points. Can you see it is again a sine wave, but in the opposite direction of the displacement. So this is what I have to tell you today about the solution and also the different cases of the solutions and how you can picture it in a graphical way. So I'll just show you some this is an animated figure. So you can see here the velocity. So first, here it is, displacement. Here, just look at the displacement. This is a displacement. So displacement, you can see that it is a sine curve starting from 0, popping up at t is equal to, what is this point? T by 4. This again t by 2. Then 3t by 4. And this is the whole time period. It's a sine curve. As against acceleration, just concentrate here. So you can see that the sine wave in the opposite direction. It starts with 0, minus a omega square, then 0, then maximum is a omega square. This is a omega square, and then coming back to 0. Then look at the velocity. It starts with maximum a omega, then comes to 0 at t by 4, then it again goes to minus a omega at t by 2, and then back to 0 at 3t by 4, and a maximum a omega again at t. So thank you all. Hope you understood the relevance of the solutions of SHM. So it's really interesting. Please do learn. And thank you all once again. Stay safe, stay healthy. Have a great day. Thank you.